Hello everyone, this is our project on automatic name-based software bug detection during static program analysis. Our team members are Dipu Dal, Mr. Sangimire, Umesh Karki, and Sirsak Acharya. This project was done under the supervision of Dinesh Pania sir. Now let's talk about the dataset we have used for this project. We have used a C Code Corpus dataset which contains 720,000 C language file from around 5,556 repos. Some repos are shown in the screen as you can see. Each repos contains C files. And finally we used os.org function to get all the 772k C files one by one for the purpose of fine-tuning CodeT5 transformer for the generation of positive and buggy code samples.
After the pre-processing of the data, we go ahead and create positive samples using AST, where only the required features are extracted. The steps for doing so varies both for the cases of wrong binary operators and function argument swap. The creation of the positive samples paves the path for the generation of negative sample. Within the negative sample, we further have two cases, one for the wrong binary operator and two for the function argument swap. So, for the wrong binary operator, we look at the operator with its possible swaps. For example, a less than operator can be replaced with less than or equal to operator. Now, for the cases of function argument swap, we swap the arguments of the two functions and a buggy sample or a negative sample is generated. And we further continue the proceedings.
Let's go into the details of model training and hyperparameter tuning. At first, the train and test dataset are loaded. We then fill empty or null data with the unknown token. The data of all the input columns are concatenated, keeping the separation token in between the data of the adjacent columns. We then split the data into train and validation dataset, making the train set 80% and the validation data 10% of the whole dataset. All the dataset are then tokenized and respective input IDs and attention masks are obtained. Hyperparameter tuning with the early stopping is done to get the best values of learning rate and batch size. Finally, the DistilBERT model is trained with the best hyperparameters and saved after the training. The model is then tested to get the final metrics.
The client-side web application was made from React.js and the server-side web application from Fast API. In the client-side web application, we have an input section for user to input the C code and an output section to view the prediction of possible bugs. Let's see an example of swap function arguments bug. Let's paste the correct code and click on Analyze button. The model has predicted the function call to be correct with the confidence of 99.99%. We get this confidence score from softmax function. When we swap the function arguments name, file and mode and click on Analyze button, we get the prediction that the function call is buggy with the high confidence. To demonstrate the wrong binary operators bug, let's paste our correct code and click on Analyze button. The binary operation j is less than yarn count seems to be correct. Now let's swap the less than operator with less than and equal to and click on Analyze button. The model has predicted correctly that this is a bug. Now let's change the operator to be greater than. We can see that the model has predicted it to be buggy with high confidence. Let's see some cases where the model has predicted wrongly. In this correct code, the model has predicted ACK function call to be buggy, but it is actually correct. This can be due to the less meaningful arguments like 3 and yarn. This correct binary operation has been predicted as buggy by the model. Again, this can be due to the presence of less meaningful operators in the binary operation. The application can show both types of bugs at the same time. To demonstrate it, we have swapped the function arguments of one function and also changed the binary operator of one binary operation. When we analyze it, we see that both types of bugs have been detected in the result. When we click on Analyze button, a HTTP request is sent to the REST API endpoint of the server. The code is then passed to a user-defined function named generate_ast for the purpose of generating abstract syntax tree of the given code. The prediction is generated from the two models one by one, getting the input features from the abstract syntax tree. We then concatenate the results from both models and pass it to the frontend in form of JSON. Thank you.